Hello, my name is David Majeski, and I am a senior in environmental science at North Carolina State University. Today I will be discussing several methods of bioenergy production that North Carolina State University could implement to offset their annual energy consumption. North Carolina State University is no stranger to energy. In 2014 alone, almost $29 million were spent on 2.48 trillion BTUs of energy. This equates to $11.66 per million BTUs of energy. Because this is a large enough energy expenditure, the need for sustainable energy is at an all-time high. Today I will argue for the use of several bioenergy production practices that could offset some of the energy expenses of North Carolina State University. The three feedstocks I will be discussing are short rotation woody crops provided by the G.W. Hill Demonstration Forest, agricultural waste from the Lake Wheeler Field Laboratory livestock farms, and municipal solid waste produced by North Carolina State University. The G.W. Hill Demonstration Forest is a 2,450-acre forest located in Durham, North Carolina. The College of Natural Resources currently uses the areas of the forest for various summer camps and educational events. When considering using forest lands and materials for energy consumption, I believe that keeping the area of use to one forest would be more efficient and beneficial than spreading the operation over several various locations. Furthermore, the Hosley and Schenck forests are small and wouldn't provide much energy by themselves anyways. For a short rotation woody crop feedstock, I would recommend using 2,000 acres of the G.W. Hill Demonstration Forest. This still leaves 450 acres of the forest untouched for the College of Natural Resources to conduct their summer camps and other various educational events. Two bioenergy conversion methods that could be used are fermentation or incineration. Fermentation would involve collecting the short rotation woody crops and herbaceous crops from the forest land and processing them to collect their energy contained as a liquid fuel. If North Carolina State University fermented 2,000 acres of short rotation woody and herbaceous crops, only approximately 23 to 182 million BTUs of energy would be offset yearly. Incineration of these short rotation woody crops would provide more energy yearly than fermentation could. 217 to 272 million BTUs could be offset yearly if 2,000 acres of short rotation woody crops were incinerated for energy production. While fermentation or incineration of these crops does provide a yearly energy offset, it is so minuscule compared to the annual energy usage that I question the feasibility of using this feedstock. Even the highest estimate of 272 million BTUs of energy offset only equates to a little over $3,000 saved yearly. It would likely require more money to harvest the short rotation woody crop feedstock, transport it, and then convert the feedstock into a usable form of energy. Furthermore, a fermentation or incineration facility would have to be built as well. Instead of trying to harvest a feedstock for bioenergy conversion from Durham, I would suggest North Carolina State University look closer to home to find a more adequate answer to offset the annual energy consumption. North Carolina State University is home to several livestock farms located at the Lake Wheeler Field Laboratory. These farms house 190 dairy cattle, 80 beef cattle, 1,350 swine, and 4,500 head of poultry. Often waste from livestock is used as a crop fertilizer, but the solid waste manure from these animals can also be used for energy production. Gasification and anaerobic digestion are two bioenergy conversion methods worth considering for solid agricultural waste feedstock. Gasification of the solid waste manure would yield significantly less energy than anaerobic digestion could. Gasification of all the agricultural solid waste produced by the livestock farms would yield a range from 644 to 1,288 million BTUs per year. Anaerobic digestion would yield significantly more energy as biogas, considering that it is 3 to 6 times more efficient from an energy standpoint. With anaerobic digestion, the expected output of energy yearly for all of the solid agricultural waste feedstock is 3,836 million BTUs per year. This conversion process would be capable of supporting various energy needs for the farms and facilities nearby. As long as the livestock farms are operating, the feedstock used should be relatively constant, with only minor fluctuations occurring mostly from small adjustments in the number of livestock present on the facility. Unfortunately, even this estimate of energy produced will only offset less than 0.2% of the university's overall yearly energy usage and only save approximately $45,000 annually. While an anaerobic digestion bioenergy conversion system located at the Lake Wheeler Field Laboratory would be financially feasible, to have a greater impact on North Carolina State University's annual energy consumption, using a more readily available feedstock will be necessary. Municipal solid waste is a bioenergy feedstock in abundance at North Carolina State University. With 30,644 registered students attending class on campus in fall 2013 and the increasing student population, we can expect this waste to be in a stable supply when classes are in session and when the energy demand will be the highest. Two conversion methods to consider when using municipal solid waste feedstock for energy production are gasification and incineration. Gasification of municipal solid waste would produce mostly biogas with some liquid and solid fuel also. Using the number of registered students attending class on campus in fall 2013, we can estimate that the yearly energy produced from gasification of North Carolina State University's municipal solid waste would be around 19,000 million BTUs per year. Incineration of municipal solid waste involves burning the solid waste to release energy, which also produces a large amount of carbon dioxide. Incineration of the same amount of municipal solid waste from North Carolina State University could yield between 15,000 and 89,000 million BTUs per year. While incineration is definitely the more efficient conversion method from an energy standpoint, gasification of municipal solid waste is more environmentally friendly due to the decreased amount of carbon dioxide emissions. Both bioenergy conversion methods have a lot of potential to offset the annual energy usage at North Carolina State University and save hundreds of thousands or even millions spent each year on energy. North Carolina State University already implements composting and recycling programs to limit the amount of municipal waste that is sent to landfills. However, this feedstock would require more effort from the university to use. Instead of sending leftover waste to a landfill, the university would need to transport it to a facility for gasification or incineration and then transport it again to a nearby landfill. Now that three potential feedstocks and various bioenergy conversion methods for each have been reviewed, I suggest that North Carolina State University implement a combination of these practices. I would recommend that North Carolina State University use a gasification system near East Campus, likely nearby the Lake Wheeler Field Laboratory. The gasifier would be able to use the solid agricultural waste feedstock from the livestock farms and the municipal solid waste feedstock from the whole university. Between these two, the gasifier could offset approximately 20,000 million BTUs annually, which could save the university several $100,000 yearly as well. Furthermore, the biogas from the gasifier would be a more sustainable source of energy for the university than an incinerator would supply. In gasification, oxygen is used as an input for pyrolysis but is limited in order to not fully combust the biomass feedstock used. This allows for several various biogases to be produced, including hydrogen gas, carbon monoxide, carbon dioxide, and methane. These gases can then be burned to make steam and turn turbines for electricity generation, or they can be used to provide heat. Due to limiting amounts of land nearby that could be used for bioenergy production, I do not recommend that North Carolina State try to use any plant feedstocks. They are simply not an energy-rich enough feedstock to be used in enough quantity on the minimal amount of land available for them. Furthermore, while agricultural solid waste is more energy-rich than short-rotation woody crops and other plant feedstocks, there is simply not enough of it being produced at the Lake Wheeler Field Laboratory livestock farms to make much of a difference in the annual energy consumption of North Carolina State University. The only feedstock in abundance enough locally to offset the yearly energy consumption by any amount is municipal solid waste, and for that reason, that's why I believe it should be used primarily. Thank you for your attention during the presentation, and please have a wonderful day.